black. Okay, everything will be seen as a green on black. Is it all right? Okay, so let me go ahead and then get to the, see, any other college wants to just give a feedback, please put it in the chat. I'm going to come to them right now. Okay, what I'm going to do now is I'm going to modify the first program that I did. Okay, I did a client server program where a client is opening a socket and taking the messages to the server side, and the server is just printing whatever the client has sent. This is the program that I have shown you as a first program, how you write sockets. Now this is what we have done so far, how you write the client side socket, how you write the server side program, and what are the issues with that. Okay, right. What we're going to do now is we're going to show you what kind of problems you will get on the server side program. Okay, and how we're going to modify that program using threads. First level I'll use threads, then later I'll show you how to actually use a pool of threads, okay, a set of threads which are pulled together to be able to do a better job on the server side. Okay, now let us go to the server side. This program on the client side we have looked at already. Okay, we have looked at the client side program. This is the program that we wrote. In fact, if you look at the way I'm doing, I'm taking the same program and modifying it continuously so that there is a flow of thread. This is a client side program. This is opening a socket connection. This is opening a socket connection to the 10.6.9.81. This is the place where the socket connection is opened. Okay, when I open in this more, I'll have a problem in terms of opening it. Let me see if okay, I have to use some other editor. Okay, I think I'll switch to my original editor only, because without that I won't get the. So this is the place where we are opening the socket. Okay, this is where it's opening to the server side 10.6.9.81. It is running on a port number 8127, and you are opening the socket connections to write a string. Okay, this is where the you are writing to the message to the socket, and it is being read out by the server side. This is the first program that we wrote. Now the question is, when we go to the server side and run this program, what happens server side program when there are multiple requests? Okay, that's what we are looking at. What are the difficulties that we are likely to face in the okay, so what we did is we actually took the this program. I'm actually modifying program repeatedly. This is what I actually got into the thread program already here. Okay, I modified this. So let me go into the first program that we wrote. Hopefully this is the program. I've actually rebuilt the programs back. So this is the program that we wrote, first program that we wrote. Okay, where there's a simple server here. Oh gosh, this is also not the program that I think we have written. First program. Okay, the first program that we wrote is the program where we don't have a server, a thread. We just have a simple thread program. I think I've modified. I'm not able to find the first program that I'd written. Is there a version 1 or something somewhere? Let me see. This is version 2 in the client server. There must be a version 1 here. Yeah, version 1. Okay, this is the first version that we wrote program. Okay, hopefully I'm seeing that this is the program that we wrote in the beginning. I find it. That's a problem. Okay, so I probably lost it. That's why now I kept putting the. I think this is the first version that we wrote. Okay, we actually took the server. On the server side, we are just setting the class called new server, and this is the where the server is opening its socket connections. Okay, server socket 8127. This is the place where the server opens its new socket, and here is the point where it starts accepting the connections from the client. ss.accept will accept the client request. Then you get the client socket. read from the client socket. This is a place where you're reading this client socket value message, and then you're printing it out here. Client says the blah blah following thing, okay, whatever I printed. Now what we said is the problem with this program is when the next client wants to accept the message, we send a next client wants to send a message to the server, unless the server finishes all this, it is not going to accept a new client. Please look at this while loop, okay. This whole while loop will get executed, all these statements will get executed. From here it accepts the connection, then it reads the client's message, and then only it comes back. After this the while loop comes back. That's the time the server can accept the second client request, okay. Now if I put thread.sleep here, okay, if I just introduce a thread.sleep into this, you are in trouble, because what happens is, if this is for a very long time, this is going to get caught. For example, all that you do is now say that this is whole thing takes a lot of time for this to actually finish execution. If you put this thread.sleep here, it means that this thread is going to take a lot of time to finish. It is not going to finish. I put a artificial sleep here, but then it can be a piece of code that it is executing, okay. So unless the thread has finished, or this particular program segment is finished, you are not going to come back to this line. So what this means, the server is blocked. Once it accepts one client request, it is blocked for a very long time, and other client will not be able to work with this, because the client will not be able to accept the requests, other clients requests, till it finished with this whole computation here, okay. This is obviously going to block the response. If you run this program, what you will start seeing is okay. So that's the problem, okay. So if you run this, you can easily see that the second client that wants to contact the server will get blocked for a very long time. We can in fact run this program and show you that this is going to take really a lot of time. In fact, the other program that I'll modify also will have the same problem, okay. So if you, let us see if you have modified this. So I've given this now, so you can see that this is there. So let us just run this program, okay. Okay, so you can run this server now. The only issue with this is when we want to, now the client starts contacting this server. This is where the client program is now, okay. Now see if we are able to run the client this side, okay. I run the first client, I give the string, it comes out, okay. But the server should not have finished, because the server took this and try to run a second client, okay. Now put this one here. It comes out here, but then see what is happening on the server side, okay. The server side, as this program is running, it's still running quite okay, because the second one also it accepted, the second ID of the client also it accepted. This not the behavior that we are expecting from this program, okay. Let us see if we made a mistake, because we just set the thread.sleep. This would have caused, there should have been a this is possibly this is not the behavior that we are expecting, okay. There are reasons for this. I think what I've done is I've artificially, I need to introduce a bigger bigger loop here. Thread.sleep will not make this program no, there's a thread which could mean not this thread, but the sleep on the not the current thread that I'm actually using. So it could be some other thread, okay. So it's still behaving correctly and not actually getting blocked on the client side, okay. Yes, so I'm seeing some problems, so I have to come back on this particular thing. We'll come back in a minute to this, okay. So this is not exactly the behavior this server program should have, okay. let us see a slightly different one. I'll come back to this. Probably I'm actually, you know, let us look at the thread version of it and the sleep part of it. I think I have introduced the thread sleep in the other one where I've created a thread and made that thread sleep. That probably works correctly. Here I have to check which thread is actually getting to the sleep because it still is responding. The server is responding. Okay. So we need to actually fix the problem as far as that program is concerned. First program is concerned now. Okay. I'll try to come back to that and fix the problem. This is what we need to understand. If the program is not behaving the way we would like it to behave, okay. Let us see if the modification of this with a thread thing, okay. That's I think is what we are calling as the version 2, okay. In the version 2, I have introduced the sleep of it, as you can see. So let us see what is the thread part of it. Okay, this is how we are going to write the program using the threads. Okay, what we are doing is now we are taking the entire program that is part of the server code here out and putting it as a second thread. As you can see here, this is a new server. Okay, and what I'm trying to do now is once you accept, this is the place you're accepting. Okay, in the previous program, this is the place where you're accepting the server connection. Okay, right now the rest of the code, processing code, is taken out and put into a separate thread, which means once the socket is created, I no longer want this to be blocked. So it will just create a new server thread to process this request and come back to it, which means it should be able to accept the next request immediately. In fact, if you introduce a big for loop there, which will take long time, then it would not have come out of it. Okay, whatever the previous program that we saw, instead of sleep, if we actually introduced, because the socket must be interrupting that program, the sleep program might have been got interrupted by a message arriving at. Okay. But if you put a active busy loop there, for example, some for loop which will execute long time, we can show that that program will block. It will not come back to this accepting another client request easily. Okay. Now what we are trying to do here is take the this is the server accepts this connection. So the client socket is here. Okay. Once I've created this, I'll just spawn off a new server thread. This will take this socket, client socket, and process the request, the server thread request. Okay, st start, this thread is started here, and then once this thread is started, it works independently, and I come back to this to accept more requests. Let us see how I'm writing the thread. This is the only place where I've introduced thread. Okay, how do I write threads in Java? This is how I'm going to write the threads in Java. Okay. So what I did is there is a class called server thread. Okay, it one way to actually write the server is by using the keyword implements runnable. Runnable is an interface. Okay, so you can say by implementing this runnable interface, you make this server thread now into a thread can run concurrently or independently. Okay, so what you're going to do here is, as you can see, any thread that you're writing in Java has three parts. One is the constructor part. The constructor part just initializes. For example, in this case, it takes the socket that is given by the client and puts it into this socket inside the server thread. So you are just initializing the socket that you had received to the socket inside the thread, server thread. Okay, this is the constructor. So constructor is just accepting the client socket and initializing it. Okay. The second part is the void method, run method. The run method specifies what this thread is going to do as part of running this thread. Okay, the run method is essentially implementing what we have earlier done, reading from the socket, client socket, printing the line saying that client says blah blah. Okay, this code has been moved into the thread now. This code is originally in the while loop there. Okay, opening a socket connection, and client socket connection, and reading the value has been moved into the thread now. So this is part of the run method. Okay, all that I put is now the same socket, the same string is read from the socket. Okay, the BR2 is the socket stream that is opened. I read a line on this and I print this whole message, and I say client says the following string has been sent. The server says the following string has been sent by the client. The start method, all that I'll do is as part of the start, as you can see here. Okay, when I'm starting the the thread, I probably has to, for some reason I'm actually changed this to show some part, but then it should be start here. Okay, the idea of the start is once you say t dot start, the thread start, it becomes independent. If I had put actually run here, it will start running the thread here. Okay, it doesn't make it independent. Okay, so what I have here is a start method which says that when you say thread dot start this process, so all that you're doing is now create a new thread, of the server thread. So you're saying t is a thread, it takes this current one and then makes it into a new thread, and then you are starting that thread. That's all you're trying to do here. Okay, so these are the three methods that are essentially part of the runnable interface. So you are making a constructor, initializing it, then you are actually writing the run method. Run method essentially took that code out and put it into the server thread. A start method will just say that if there is no thread, then you actually create one and then start that thread. Okay, it's all that it's doing is starting this thread as an independent thread. Okay, now the current client server program, the server program gets modified now. As you can see here, while true, earlier this whole program which I have commented out is in the same place. Okay, now instead of that, what I've introduced is I've accepted the socket, started a new server thread which I've written up there. That whole code that you saw there is a server thread class here. Okay, as you can see, this whole thing is been written as a server thread here. Okay, server thread implements runnable interface. Okay, right. So this whole thing is what is created here. So in this client server program, what I'm creating is a new server thread, giving this socket that which will be initialized in the constructor part, and then all that I'll say is start this thread. Okay, once this thread is started, it becomes independent, and this program comes back to this statement. Okay, I'll just come back to this statement. Okay, that's how this is. This will be working. Okay, so each time you have started this, it's going to create a new thread. Each time you accept a new client request, it will create a new server thread and give that socket ID, that's client socket ID to this, and it will start running as a fresh thread. Once this st start is done, this becomes a new thread to be run. Okay, this is what the original program has been now modified, saying that every client request will be processed in a new thread by the server. Okay, in fact, we can see this version possibly. Okay, I think I've created multiple versions. That's a problem. I've actually started creating multiple versions, so I have to realize which version I've created where. And okay, now if you run this code, okay, this basically will take, this will run exactly the same way as the other one, except it will try to create the, if you create now the client and then put this string there, this will go to the server side. If you create stream is open, the client say actually this is Jankiram. Okay, and then the socket created, and again this is going back in this second thread. Again you can see that the thread, once I've given one more request, again one more thread is created and it is actually executed it. In fact, you can try this program in multiple ways. You can start opening multiple clients at the same time, which will all open the same. If I can actually go to the other machine and at the same time ask my student to open this thread, then you can see both of them will race with each other. Whichever is able to open the socket will create the thread. Once the thread is created, it will go back and then start doing the other work. Okay, so this is lots of interesting things about thread. The JVM itself runs a lot of threads, including the garbage collector inside the JVM is also a thread. Okay, one good thing about Java is it supports these threads quite well. Okay, the JVM itself is written as threads. Say somebody says now it's okay. Somebody says no audio. Okay, is everybody with me? Are there any questions at this stage? I think I've started becoming faster now. So if you have questions, please raise it on the chat box. Okay, right? Now the lectures will slightly become deeper from this point onward. So I'm just showing how you will actually modify the client server program. I'm assuming all of you are with me. Okay, right? If there is any issue, please raise it at this point. Please raise. Is whatever I've done clear? Is there any question? Please raise the chat box now. Can people say, have you understood now why we need to? Desktop sharing is a little bit slow. Okay, is it not showing up? Is that the problem? 48. Is the desktop showing is slow means what? The desktop is not coming up as I'm showing. That may be a bandwidth problem. Okay, I can go a bit slow, and make sure that your thing gets synced or whatever it is. Okay, maybe the bandwidth at your college is a bit low. Okay, please check your bandwidth. Okay, now okay. So any other question is what I took an initial program. Okay, initial client server program. I'm showing what is the problem with that client server program. What I'm trying to do is now change that program into a thread program. Okay, right? So this shows how I've created the threads. I'll go back to this program once again, show you before I start modifying this program again. Okay, this is what the program we are in now. All that we have done is to just give you a recap what we are trying to do. All that I'm doing is now, instead of processing whatever the client requests into the main program, I'm actually creating a server thread. What the server thread is, this is a new thread. Every request from the client will get into one separate server thread. This is how we are writing our program. Class server thread implements runnable. I can also use extends keyword in Java, extends thread. I could have also written the same thing as extends thread. Okay, the two ways in which in Java you can create threads. Either you can say extends the thread class or implements runnable interface. Okay, I've chosen the implement runnable interface. Now in this, I'm creating a thread T, which will become a local thread which I'll spawn off, and I'm creating a socket SST, which I'm actually taking the client socket and then initializing it to this socket. I'm creating an input stream reader R2, which earlier I've created it in the main program there. Okay. Now once the socket is opened, the server accepts the client socket, that is this S. SS accept is basically S. We are now giving it, creating a new thread, server thread, and passing this socket S here. Okay. Now I'm initializing within this thread the server socket, the client socket to this S, and saying that the socket has got created. Okay. Now this, I'm writing the run method, which is essentially doing all the work the main program is doing earlier into this server thread. Okay. Now you can see here in this case, I'm in the in stream from the socket. So this is the socket that I've accepted. This is the client socket that I've accepted, and I'm asking on this get input stream. Okay. Now I get the input stream reader R2, which I've defined there. Okay, at the top you can see that. Now on top of this, I'm actually making that as a buffered reader. I'm just giving this R2 and creating a new buffered reader so that the incoming requests are actually buffered and I can read one by one. I'm making this buffered reader ready. I'm just reading this one line from this buffered reader. That is the string that I've got now. I'm just printing this string saying that client says blah blah this. Okay. Now I'm writing the start method. All that the start method is doing is starting this thread. If there is no thread available, if T is initially null, I'm creating a new thread and I'm just making this thread. I'm creating this server thread as a new thread. Okay, and I'm starting that thread. That means it becomes an independent thread that's going to be executed. Okay, this is what the server thread is about. The public class new server, this is what we had written earlier. This is where the server socket is written. As you can see here, this is a server socket is SS. Now I'm creating a new server thread ST, which I will start off here. So as I'm getting the new request, this is a place where I'm accepting. The server socket is created here as an SS, and this accepts the client request. This is when I got the client socket. Once I got the client socket, I'm creating a new server thread. I'm actually giving this client socket here as a constructor. As you can see, this is made equal to SST in my server thread there. Okay, this is a new thread that got created. All that I'm saying is now start this new thread, and I'm off to. Okay, once you say st.start, that start method will be executed, and that will start the t.start, and then this program will go back to accept into the while loop new client request. This is how this will keep working. Okay, is the program clear now? Earlier I have all this code, this place, whatever I have, this part from here, I was having this other part, whatever is read in commented lines. I've introduced this as a thread program now, change this into a thread program now, and using this as a thread program. Okay. The nice thing about this lecture is I'm using the same program. I'm modifying it. I'm showing you what I'm doing. Okay. I'm running this program, showing how this new program works compared to the previous program. Okay. Now, is that clear for all the people what I've done? This is actually, I assumed people can very easily work with threads with Java. Okay. If you have any question, please stop me at this point of time. Okay. Okay, so I think some college has a problem with this background. So see this background if this is all right. Okay, this is a program that I've actually shown. This is absolutely, it's not using anything. All that it is doing is just simple black on green. Okay, this is the server thread implements runnable interface. This is the thread 3 socket SST, the same program that I've explained. I'm just not using any color coding here. All that I'm doing is just a black on green. Okay. Now, is that clear? Please read this program, and if you have any questions, please ask me. If there are any questions on this, please raise it on the chat box. Okay. This is what the program is doing. Okay. Start, and then the rest of it is just the commented section. Okay, right? Okay. Are there any questions on this? Please raise it on the chat box. Okay. Required import statements. Okay. The import statement, you don't need to change anything because threads are part of already the Java fundamental constructs. So you don't need to actually do any additional imports as far as this is concerned. If you're doing the some additional frameworks, then you need to actually import java.util.concurrent. That I'm going to show you later. Right now, for this program, you don't need to import anything else except the Java, import java.io and import java.net. I'll give you access to all the versions of the program that I'm developing, because this is how I'm teaching you actually. Okay, I'm teaching you by changing it and then showing you how the whole program should have been altered if you understand the concepts fundamentally. Okay, the first one which we did, we are not no writing the server code correctly, because if the server has a lot of work to do, it will block the clients when they send the requests. Okay, right? By making it into a separate thread, you will not have this problem of server thread getting blocked. Okay, right? So that is essentially the idea of this program here. Okay. Any other questions that you have? I'm also showing this one more time in the simple plain this thing. Okay. Any other questions people have? Please please show the import statements. I've shown that. Okay. Let us use the question box for asking questions. Other things we use the chat box. Okay. Is there a question box somewhere? I am not seeing a question box. Where is the question box? Somebody is saying there's a question box. Where is the question box? For me, please put it in the chat, because I'm not besides the viewer tab. Is it okay? Okay, question tab. Okay. Okay, I saw that. Correct. Okay. But then anyway, you can raise the chat also. Okay, question tab is right next to the. So if you have a question, please put it in the question tab. I'm actually in the question this thing right now. Okay. So is this clear now? I'm going to go a little deeper. Okay, one of the interesting things about Java threads is JVM fundamentally supports Java. Every program that is running is actually a thread. Okay. Uh, can anybody answer this question? Java supports garbage collection. Okay. What do they understand by garbage collection? Okay. In my program, I'm using the new. Okay. In Java, do you use delete anytime? Do you use delete in Java? Can somebody answer this question? Final method. That's not correct answer. Okay. In C++ or C, do you use delete? Do you use a similar delete in Java? 48 is saying no. Okay. Why were you not using? So all the constructed objects in Java, how are they freed up? For example, I'm creating lots of new objects. First is, where are these objects created? That itself is a good question to ask for. Okay. Assume they're created somewhere, Okay. But now, who is actually freeing up these objects? Okay. One of the very good things about Java is there is something called automatic memory management. Okay, which means that Java as a language supports automatic garbage collection. So what happens is, there's a inside the JVM there is a thread running which is called the collector. Okay. Now what the garbage collector thread does is, every so often it looks at every running program and sees if there are there are objects that have become garbage. It starts collecting those garbage objects. Okay. Now when the garbage collector thread comes and then collects these garbage objects within the JVM, okay, it tends to stop all the running threads, because it's collecting now whatever is garbage. Okay. So one of my students, in fact, had done extensive research work on trying to make the Java garbage collector work without stopping all the other threads. Okay. And he incidentally called this collector, garbage collector thread, he redefined the Java virtual machine, putting a new garbage collector thread. And he actually called this garbage collector thread as Yama. We all know what is Yama, right? So this Yama thread inside the garbage collector, inside the JVM, goes and collects all the free objects without stopping all other threads from. No, they don't need to stop. They can start running, but then for a little time they will be stopped. The collector thread will come, collect the garbage, and then put it, freeze them up. This is one of the good things about Java. Java provides, frees up the programmer from understanding where to write these free statements. In my program, all that I'm saying is a new here, okay? And I'm never writing. I only create new things in my program. I never worry about, freeing that up. And once some object here becomes free, it becomes a garbage because it has gone out of the scope and the program is no longer using it. The garbage collector thread detects that and then collects the garbage objects, okay? Right? So there are a lot of interesting things about Java programming language. You can see here, we are now automatically writing, okay, these multiple threads that can be executed simultaneously. How would I have done this if I'm actually doing it in C? How will I create multiple threads of execution in C? I was asking this question long back. Somebody answered this question saying that this is okay. Okay, I need to come back. How would you have written this in okay, in C program? If I'm writing this in C, this is what I would have done. Okay, a C program, what we do is we use this fork system call. Okay, in the program we'll say fork. This fork is a Unix system call. This is a Linux system call. There is nothing in the programming language to create threads. Okay, C program, if you want to create two different execution threads, you have to use this system called the fork. Now fork will return a 0 in the child process. It creates two identical processes. One a child process, the other a parent process. Okay. Now you can see when the fork returns a 0, it means that I'm in the child program. I can say child program hello Janakiram. The rest else is actually the parent program. Okay. So there is a parent process which creates a copy of itself, which is called the child process. Then in the child process, this fork will return a 0, and in the parent program, it returns the child ID of the child process is returned here. So here I can say parent program hello Janikran. This is how I would have written if I have to write a multi-threaded program using C. In fact, you can just run this program. There are a lot of differences between using this kind of constructs. Okay. This is just a warning, so we can ignore that. Okay. So this is what it will print. I have one question for people here now. What is the difference between writing the concurrent program in C versus Java? Okay, I'm using the fork system call. Okay, right? Yeah, the Vijayanagaram campus is saying I can also use pthreads. Pthreads is again a library. I didn't get into pthreads. If you're using pthreads, then it's actually a again a library call that we will be using. Okay. Is there any chance to get the material for this course, sir? Yes, I will actually give you the material for this course. It is actually I gave in the first class itself. I'll repeat it again. Okay, we'll repeat it again for you in the in the end of the class. Okay. Now I'm asking this question: what's the difference between using a concurrent program? Question box. Okay. Okay. I'll come back to this particular. I'll use the last 10 minutes for interaction, but let me ask this first question. Okay. What is the difference between writing the concurrent programs in using a fork versus the thread program that I've done in Java? Okay. Are there answer for this? Can somebody answer this question for me? Yes, that's excellent. So operating system and the JVM. So what do you mean by operating system versus JVM? Okay. Can you further elaborate? If I write the threads in Java versus fork in C, what will be the essentially the problem that I'll face in C but not in Java? C and C++ request OS, and what happens in Java? So what happens now? Can the C and C++ programs, JVM does it? That's fine. This is the first class where I was telling what is the problem with writing the network programming using Java versus network programming using C. I'm just repeating that question here. Okay, but you should be more specific. What would have happened is, if I write my C with a fork program, it will not run on Windows operating system because Windows doesn't support a fork. Okay, but whereas if I take my Java program from my Linux box to my Windows box, it will still work because the JVM there supports the yes, multiple processes are created, but in Java threads lightweight process are created. Okay, uh, who is asking this question? In C it is multi-process are created, but in Java thread, I think that is probably not a complete understanding of the difference between process and the P threads is basically a lightweight process. Lightweight process are in the same memory, so the context switch time is less. Fork is a heavyweight thing. So use P threads, possibly you will get a lightweight thread option, even in the case of C also. Okay, the only thing is you have to use a different library. The lightweight actually means the context switch time is less. You don't, the threads share the same memory. So what is switched between two threads is essentially the PC, the program counter. Okay, the rest of it will remain the same. Okay, right. More interestingly, what I want you to understand is Java has taken a lot of abstractions. See, I think is Ramakrishna on there? Ramakrishna, I think there is a message here. I think now I've come to some stage here. I would like to see if there are people facing, this Sri Krishna Mamilapi is saying that as we are not able to get synchronizing audio and video, can you send last 3 recorded sessions, please? Okay, uh, right? See, what is the problem? This seems to be a problem out here. Okay, this can we get that viewer and then see if he's publishing his video first? I would like to get his is he publishing the video? Well, ask him to publish the video. Can you publish your video, please? Then we can see if this Sri Krishna Mamilapalli, can you publish your video, please? I want to have an online chat with you. Right? We would like to see if this, I just want to see if I can, I'm still seeing he's not publishing his video. Okay. Can you publish your video, please? I want to have a direct interaction with you. Can you publish your video, please? Can you publish the college video, please? Maminapalli, uh, Sri Krishna Maminapalli, can you publish your video, please? Would like to directly come to you. Can you just? Meanwhile, is anybody else having the same problem? Are there similar other problems? Am I now? See, I'm somewhere getting lost now. So continue your session, okay? So do I now just go ahead with my session? Anybody else has question? I think we're still getting used to figuring out what is the right thing to be doing in. Okay, so we would like to spend some time understanding if there are real problems. Okay. I don't know. I'm getting a little confused with this chat box that I'm getting now. So this is what we want you to understand. So if I just have to go back to my lecture thing, all that we are trying to do is we are trying to create these new versions of the program. Can we identify what is the problem with the just now program that I wrote? Actually, if you look at this program, this also is not a very good program to be writing. Okay, the real programs are not written. I guess I have a version 2.21. Okay, now I have a version 2.2 also for this. Okay, now let me show you what is the kind of problems that we will get into if we see these programs. Okay, now I write this program, then I typically, let us say I'm actually introducing this thread sleep here. As you can see, if this thread is made to sleep, okay, after one thread, as you can see, this thread can actually now be sleeping. Okay, this need not come out of the out of running. Okay, now to just show you the problems that I can into, if I instead of start I include this program and say directly run this program. Okay, I initially will not, I'm just trying to modify. Trun would have made it, okay, any of these places where there is a start, if I directly run this program will for example here if I put t start run, this should actually get blocked. Okay, the reason is you are trying to include the entire code. Unless you finish running that, it should not be able to okay, come out of that. Once you say start, I'm trying to make it as a new thread. Please understand the difference. Okay, a run would have started running that piece of code that is part of that particular thread. A start would have created it as a new thread. Okay, now let us see what would have happened in this case if I have the program like this. Okay, okay, I modified it. Please remember, I modified and I have to go back and then correct it if I'm actually okay. Now let us say I start this in the while loop. This is the first while loop that I've gotten into. Okay, now I have to start the server program here. Okay, client program. So client program, all that I'll do is, this is a new client here. I'll put here my program here. I'm just trying to, first program has come out. Next program will also, this side will come out. But let us see whether the server is able to respond. Okay. Now you can see after the first while loop, it has got stuck because the program is now trying to execute that entire with thread sleep 10,000. It is trying to execute. Okay. So even though I had actually given a second client request, the client request is not accepted here. Okay, because the thread is executing and it has actually got into this loop of it slept. Now unless it's executed all that instructions, it is not going to go back and accept a second okay. Now let us modify this program and see if this behavior is going to change if I actually make it into a thread. Okay, so wherever actually there is a run, I'll make it into a start. Okay, so I have this T run, which becomes T start. Okay, this is only going to be, so the behavior is once you have started this, to go back and listen to the next one. Okay, so it should not get blocked. Okay, as I saw right now, this should not get blocked. Okay, if I modify this in this particular way, let us see what happens now. Okay, okay, now if I run this new server program, I'm in while loop here. Now let us see if I start giving, I run a new client. Okay, first client, I do a second client, give this, I've got into the second client. Let us see how the server is behaving now. You can see now here, this is where the server has started. Okay, now you can see in the while loop. Okay, it started the thread here. Okay, it started the thread. Then immediately after starting the thread, it again went back to the while loop. Because this thread executes independently, I am in the while loop again. You can see there are two while loops already. Okay, I have already come out of that. No. So what's happening here is you're actually coming out of the thread. Okay, and the second client thread is also accepted, though that thread is sleeping. Okay, I'm into the thread now, second thread, and I've started actually executing the second client request here. The minute the second one is accepted, again I'll go in the while loop because I'm waiting for the third one to come in here. Okay, so you can see now here, the minute you made this as a thread program, a threaded program where the thread can go back and keep executing, one after the immediately. So what the program is doing now here, if you essentially what is this program? Okay, see this program here. I'm actually having the same program, except that in the class new server, as you can see here, once this st start, it is getting back here. Okay, so it's saying in the while loop and just trying to accept the next request. Okay, once this start becomes an independent thread now, this won't block. I come back. This loop essentially, this is like, a front office clerk. You call a front office clerk, he says, whom do you want? In the previous case, the person receives the call, tries to handle all your work himself. Till that point of time, his phone is busy, so if you have a busy tone. Okay, in this particular case, the front person just accepts your phone call and says, now forwards the call to somebody else to handle it. Now he is free to receive the next phone call from somebody, which means essentially this program is reducing the block time for the client requests. Okay, and that's where this becomes extremely scalable when you write your programs this way. The whole idea of writing the client server program is it is not just for one client and one server. We will be writing these programs for hundreds, thousands, and sometimes millions of clients. Okay, right? Okay, so I think that is a problem. I think yeah, I think they have an internet problem. Okay, there's a question. Okay, what's the question? Are there any other questions now on this? So what we're seeing is essentially rewriting the program so that the server, the amount of time the server is blocking is reduced. Okay, and for that we have introduced the thread. Single thing, what is the material that I'm using? I'm using the chapter 8. Please understand, I'm using chapter 8. I already gave this. I'm using chapter 8 of Java in a nutshell. Okay, but then I'm writing my own times. Okay, you can use any other book as well. Okay, I'm actually now I'll be using a framework that possibly is not part of a Java in nutshell. Most of this material I'm developing it on my own, and all these programs that I'm writing are the programs that I have developed. I'm changing them multiple times to introduce the concept and making them run for you and making them show it to you. Okay, I'm going to these versions, I'm going to make it available for you. I'm actually not destroying one version to the other version. I'm keeping all versions now. So if you want to learn, you can first see how I wrote my first version of the client server program. Then you can see how I've changed the version to the next version. Now I've introduced the threads, and in the threads I've again shown you how blocking versus non-blocking, okay, works as far as the server side is concerned. I'm going to next class, I'm going to introduce what I see as a framework, okay, further doing things on top of, even this program is not good enough. We want to further modify this program. So we're going to look at this and further modify this program to see, can I scale it up further? Please understand, in distributed systems, you are not writing programs for one client and one server. Often, when the results come, okay, so many people try to access the server for seeing their results. Sometimes within a span of a couple of hours, a couple of million people would like to come to the server and would like to know their result. That's the time server performance becomes extremely critical and important. And that's what we are trying to look at when we are designing these programs. As we understand this concept, we will see why MapReduce, the next set of things that Hadoop and MapReduce, makes it extremely easy for us to write programs as the abstractions get taken further, okay, higher and higher. Okay. So any other questions you have, just use the chat box. There is a question, if the thread sleep is not there, how multiple clients served by calling run directly? Okay, what is the question? The question is, can you elaborate the question? If thread sleep is not there, how multiple clients served by calling run directly? Okay, see, once you call the run directly, it means that it's equivalent to doing, you're not creating a new thread, independent thread. The run will be executed. Okay, this thread will start executing that body of the code. Okay, now in which case, unless that run is finished, the next instruction there is not going to be executed. For example, I think what we saw there, I think it is my I have too many things open. I think I have to go back to the I'll just answer this question and stop there. See, if the run is not there, I guess I have the window open somewhere. Yes, I think this is the window, right? Now, what your question is, if you don't put st start, if you had put st start here, then it will start a new thread and go back here. Okay, the whole processing is done by a new thread. If you put st.run here, it tries to finish this instruction run before it goes to the next instruction here, which is the while true instruction. Okay, strun would have been blocking this while loop, whereas ststart will make it as an independent thread is started and it will start executing this, and you go back to the while loop there. Okay, is that there is a question there. I'm not sure which edition. I think this must be the later edition. Okay. Okay. Fine. Okay. So same as the first example, if the thread sleep is not there, how multiple clients served? Same as the first example, right? Yeah, that's correct. But then if you putting that's what I wanted to show you actually, saying that if the processing is very small, then creating a thread for every client. For example, if somebody calls you and you're going to say, okay, I'll take your request. That's all you're going to do. Then there is no point passing that phone call to another person who will say, okay, now I'll take your request and we'll talk to you. Okay. So in that sense, it is not a good thing to be designing a multi-threaded server. You should design a multi-threaded server only when the incoming requests need a lot of processing to be done. Okay. The incoming requests need a lot of processing. Then you are going to create a separate thread that's going to handle the client request. And then the main loop of the server, which is listening to the clients, is not blocked for a very long time. Otherwise, the client response times will be suffering. As you can see in this particular case, the program is trying to the program is not accepting that second client request, is buffered somewhere until and unless the program finishes. The second one is not going to say, the second client said Janakiram, client says hello Janakiram, will not come there. Okay. Hope that is clear. Okay, these programs I'm going to share it. In fact, I'll give you an access where you can download these programs. Okay, whatever programs, multiple versions of the programs I'm running, and the same ones you should be able to run on your side also. Okay, only thing is the IP addresses have to be changed. Okay, whatever IP address I am using, or the IP, change the IP address. For both Kakinada and Vijayanagaram campus, we gave these instructions, and these Hadoop plus Bosmool, whatever I'm doing, is available for them. For the others, they have to right now look at the programs. If they want to run it, then they have to set up the environment. Okay, that we will handle it leisurely. I think with that, I'll stop today's lecture. Next class, 10-15 minutes. I'll take 10 minutes. I'll take initially the questions and then go with modifying the program again to the next version of it, where I'll show how thread pooling can be done. And if you have any questions, please have them ready for the next class on Wednesday. Okay? Yeah. Okay. Thank you. I'll be